Hi again, this is Mr. Wakefield, and let's take a look at section 2.5 today. And 2.5 in a lot of ways is the opposite of what we just did in section 2.4. Back in section 2.4, just briefly now, what did we do? We took an equation in some of these problems, took an equation, that's what we started with, and then we graphed it. Well, in 2.5, we're going to be going the opposite way, where I'm going to start out with the graph, or at least a description of it. And then you have to come up with the equation that the graph came from, okay, that's linked up with it. And the equations are going to be similar to this format. It won't have the everything in here. The x and the y will be a part of your answer normally, unless it's one of those equations that's missing a variable that we talked about that in the last section. But other than that, the x and the y will be part of your answer. But these things that I circled in green right here, these are the things that you're going to need to figure out and plug into your equation, and then you'll be able to come up with the equation that you need. And so that, at least initially, here's what we're going to be doing. So let's go ahead and realize here before I flip over the worksheet, you can use this formula if you know the slope, and then you just plug it into M. And then if you know the y-intercept, you just plug it into B. And then you'll have your equation, because the x and y are supposed to stay the way they are. If you know the slope, but you do not know the y-intercept, however, if instead you know some other point on the line that's not the y-intercept, then let's say, for example, that point was, say, 3, 5, okay? Then you would plug the 3 into the x1 right here, because 3 is x1, as you can see there. And then since 5 is y1, you would then plug the 5 into here, okay? And then you'd have to plug in the slope here like usual. And then once again, the x and y would have to stay the same, and as they should. Okay, so let's go ahead and try all of this. And let me pull out a clean sheet of paper here. Clean worksheet, I mean. And here's problem number 1. It says right off the bat that we have an equation that we need to find, and we need to put it in slope-intercept form. I'll get into that. But the description they give us is a line that has m equal to -2 and b equal to 12. Well, gee, they pretty much give the answer away to you practically right there. Okay. So what they want you to do there is just simply to take the m and the b. Remember, I just said a minute ago that if you know, and let me put it up here on the screen here so you can see it. If you know the m and the b, though, you can use that first formula, which is the mx plus b formula that we've been talking about. Okay, so there it is right there. I'm sorry, I had trouble finding it there for a second. Okay, here we go. So now, again, if you know what the m and the b are, you just plug them in. So, and again, the y and the x, they stay the same there. They stay the same. So let me put the -2 where the m is supposed to go, and then let me put the 12 where the b is supposed to go, and then of course you add whatever you plugged into the b. If the b had been negative, then that would be plus negative, which would then make it a minus. But since this was positive 12 for b instead of negative, you just say plus 12. And that's all you got to do on that one. That was a pretty simple one. Let's look at the next one now. It gives us a couple pieces of information. Notice in both of the formulas they give us, though, both of the formulas they give us, you need to know what the slope is. Well, gee, they don't tell us anything about the slope here. So what do? What you want to do there is realize that the slope can be found by taking this formula right here. Let's write it down. Slope is equal to, there we go, slope is equal to y2 minus y1 over x2 minus x1. What that means is that you take the second, if you, for example, if you have two ordered pairs that they gave you, okay, which they did give you here, all right, and I'll explain that in a minute. But if they give you two ordered pairs, you plug in the second y, the first y, the second x, and the first x into those 4 slots right there on the top and bottom. Okay, why do I say 2 ordered pairs? It sure doesn't look like 2 ordered pairs. Well, whenever you have an x-intercept, that automatically means that y is equal to 0. So if it says x-intercept is equal to -4, then that means that the y equal to 0 goes with x equal to -4. And likewise, if the y-intercept, anytime you have a y-intercept, the x is 0. Okay, that's just the way it is. Okay, because in a y-intercept is where it crosses the axis, and whenever you cross the y-axis, the x will always be 0. And that's why the x is 0 here. And whenever you cross the x-axis, in this case at -4, the y is always equal to 0 there. So therefore, since they tell us that these are the 2 intercepts, that means that these 2 points are on our line that we're trying to find the equation for. And since we know 2 points on a line, this is not the only problem that's going to be like this. The next problem is similar here, where they just give us a couple of points on the line. Okay. What you can do in order to find out the slope, if you don't know it already, is to use this formula here. So I'm going to use that. Okay. So again, you take the second x. Excuse me. You take the second x minus the first x. Okay. And so that would be 3 minus 0. 3 minus 0. Okay. And then it's kind of similar to what we saw in the circle formulas, okay? If you plug in, if you have 0 minus -4, second x minus first x, since the minus is already in the formula, just like the circle formula, if you plug in a negative number behind that minus, okay, that's going to make it a double negative on the subtraction, and that makes it +4, okay? So again, if you had plugged in a positive number, like say that this was, for example, say that this was 4 right here instead of -4, then that would be -4. But because it's a negative, it's like subtracting a negative, and we know that when you subtract a negative, it becomes plus. Okay. What is all this equal to? Well, we got to figure out what the top and bottom are equal to first, and then we try to reduce the fraction if we can. And we get 3/4, which does not reduce, and so therefore there is your slope. Okay, it is positive 3/4. Now, here's the thing. Once you know what the slope is, okay, what you do next is you ask yourself, which of these 2 formulas do I want to use? Which can I use? Okay, well, if you know what the y-intercept is, you might as well use this, because we're going to need to get it into that form, the slope-intercept form, eventually anyway. So you always want to use that first formula if you can, because it's eventually going to end up that way anyway. If you use it, you'll get to the answer faster. Okay, but if you do not know what the y-intercept is, then you can always fall back on this second formula instead. Do we know the y-intercept? Yes, we do. Okay, it's right here. Not all problems are you going to know the y-intercept, but this one you do. And the last one we did as well. And here's the thing: the b will always be the number that is matched up with x equal to 0. It's always the y number that matches up with x equal to 0, and so therefore the b is equal to 3. Okay. It's never the x number, okay? The x number is always going to be 0, but it's that y number. And so all we got to do now that we know what the m is the slope, so I'll just call 3/4 equal to m. And now that we know what b is, let's just put those 2 things together right here. And we're going to write down y and x. Again, remember, y and x are part of the answer. But the formula says to have the m, which is 3/4, make it so that it's multiplied by the m, or pardon me, multiplied by the x right there. Just like in the last problem, -2 times x, now we have 3/4 times x. And then because the b is positive, we're going to say +3. And there you go. And that's problem number 2, excuse me. Okay. Now, so that's what you do if you know what the slope and the y-intercept are. Okay, if you know the m and the b, then that's what you do. We still had to figure out the slope here in number 2, but once we did, we knew what the m and the b were, and we could just jump straight into the mx plus b formula in order to get the answer. And again, please read your directions, okay, when you're doing problems, you guys. It does say to have it in slope-intercept form. And I say that because it won't always be that way at first. It was here, but it won't always be that way at first. I'll show you that here in the next problem. So in this next problem here, kind of similar to the last one in that they do not tell us what the slope is, okay? But they did give us a couple of points. And so if they don't tell you what the slope is, but they do give you a couple of points on the line, then again, you can always fall back on this formula up here that allows you to take any 2 points on the line right here and plug them into this formula to figure out the slope. Okay, again, second y minus first y. That goes on top. So second y minus first y, that's going to be 2 minus 3, like that. And then it says second x minus the first x. That's what x2 and x1 mean. So that would be negative 1 minus 2. Okay, again, the 3 and the 2 that are behind the minus signs, those are both positive numbers, and so that's why the minus stayed as minus, unlike over here where it changed to a plus because I was subtracting a negative. Just want to make sure that you're understanding that difference there. What do we got here? We've got negative 1 over negative 3. Now, a little review here, you guys, if I may, up here at the top. Remember that when you have a negative over a negative like that, that's the same thing as positive over positive. So you could write it that way just to kind of make it look a little cleaner without all the negative signs there. And again, just as a review here, I know this is not the case in this current problem that we're working on, but you'll see it in the future and in some other problems we've already done. But if you say, for example, you had a negative outside of a fraction, please remember that that's the same thing as this right here. That's the same thing as these two things right here. All three of these fractions are all equal, and they are all what? They are all negative. Okay, both of these fractions over here are positive, and they therefore are equivalent to each other since the numbers are basically the same. So I just want to make sure that you understand how these negatives are all related to each other, and the fact that depending on where they're at, it could be the same or it could be different, like over here. Okay. In other words, these ones here are not the same sign as these over here. Okay, so it all depends on where the negatives are and everything. Okay, this is all true if you only have a single term on the top and the bottom. If you have more than one term on the top, that's a little bit different as far as how you can move the negatives around from the inside to the outside and everything. But if you just have a single number on the top and bottom, you can move the negative to the outside. You can move it from top to bottom because all three of these are the same, whether you put the negative on the bottom, the top, or on the outside. Okay, so all good things that are going to be good for us to remember moving forward here, if you didn't remember that already. Anyway, let's go back to the current problem, and notice again that we know the slope now. What we did in the last problem is that once I figured out what the slope was, okay, I then knew what the b was as well, so I just plugged them in and the problem was done. The problem, though, this time is that none of these numbers are equal to b. And the reason why is that in order to know what the b is, in an ordered pair, the x part has to be 0. Okay, let me show you. In order to know what b is, the b has to pair up with x equal to 0. Okay, neither one of these points has x equal to 0 in that first position there, does it? You got 2 and you got negative 1 in the x spot. Okay, so because of that, you can't assume that the 3 and the 2 are equal to b. Okay, the b has to, again, pair up with 0 in an ordered pair. So therefore, I don't know what b is. Okay, at least not yet. So here's what you do. You pick one of these 2 points, because remember the second formula here says that this x1, y1 thing right here, it says that it could be any point on the line, any one at all. So that's why you're allowed to choose which one of these two you want to do. Okay. I'll go ahead and choose that second one right there. All right. And so what does that mean here? Let's go ahead and follow it here. So I've got y. I'm using the second formula here. Okay. Y minus the y1 number, which is 2 right here. So I'm going to say y minus 2. And then I plug in my slope, because it says to do that before the bracket right there with the x next to it. And then you put your bracket according to the formula here. And then you put your x, which is supposed to stay the same. Again, remember, you guys, the x and y that are in red right here are supposed to stay the same. But the x and the y that have the little 1 underneath it, those are the ones that where you put the negative 1 and the 2. Okay. So speaking of that, remember x1 is negative 1. But the minus sign is already built into the formula already, and so that's another one of those cases where it becomes a double negative. X minus negative 1, same thing as just saying x plus 1. Please change it to plus to make the next step a lot easier to do. It's always nice to have less negative signs if you can avoid it whenever you're doing any step. So if you can change the double negative into a plus 1, that'd be great. And we can, so why not? Okay, so here's the thing. This is a legitimate equation, you guys. But it says, once again, that we have to get the answer in slope-intercept form. As it says here in the directions here, that means y equal to mx plus b. That's the slope-intercept form. Okay, so I need to transform this current equation into y equal to mx plus b. How do I do that? It's a couple of steps you got to do. First of all, I need to get rid of the parentheses because there's no parentheses in mx plus b. Okay, please do that first. And when we do that, we need to distribute the 1/3 to this bracket. Anytime you got a term times a bracket with a couple of terms inside the bracket, you can get rid of the brackets by distributing that out. 1/3 times x is just 1/3 x. Okay. Just like 5 times x is 5x, 1/3 times x is 1/3 x. You're just multiplying a constant number 1/3 times just x. And then 1/3 times 1, of course, is 1/3. Okay. No mystery there. Okay. Anything times 1 is itself. And positive times positive is positive, so you got to put that plus down. Okay, remember you got to have pluses and minuses in between your two answers here when you distribute to two things. And so we cleared out our parentheses, but what's the last thing I got to do? Last thing I got to do is I need to move that 2 over in order to get the y by itself. The way you do that is by either adding or subtracting it over. Since it's -2, however, we're definitely going to add it over. Okay. And so plus 2 plus 2. Okay. And so we get what here? Well, we get y by itself, because the 2's cancel on the left. Y by itself is equal to 1/3 x plus, and then what is 1/3 plus 2? Well, as we know from previous math experience, that anytime you add a fraction to something, even if the other thing's not a fraction, what you got to do is you got to make that thing that's not a fraction, you got to make it into a fraction by putting 1 underneath it. And then you get a common denominator, least common denominator, because remember, whenever you add fractions together, you need a least common denominator because the denominators need to be the same. The least common denominator here is 3. Okay. And so we need to multiply the 1 by the 3. The other one already is 3, so you don't need to change that, the top fraction. But this other one is 6/3, isn't it? So that leads to what, you guys? That leads to 7/3. Okay. And since it's positive 7/3, we're going to say plus 7/3. If it had been negative 7/3, then you put the minus in front of the fraction. You'd still say 7/3, but it would have the minus in front. But since this is positive, we're going to just say plus 7/3. Okay. All right. So that is what you do, you guys. If you figure out or already know what the m is, but you don't know what the b is, this is you can fall back on this second formula that we have listed down here. Okay, that's called the point slope form, and then you just need to do those 2 additional steps to get it to look like the y equal to mx plus b form after you initially plug the numbers in to that second formula, the point slope form. Okay. All right. Now, in this next problem here, you can see it says vertical. Okay. Stop right there, you guys. If your problem is either horizontal or vertical, doesn't matter which one it is, okay? I don't want you doing, just like I said in the last section, I don't want you doing mx plus b, okay? Don't do that. You just need to realize that, just like in the last section, that's a special separate case. And you can see I have listed here special exceptions. If the slope is 0, then the equation is really simple, you guys. You just got to know how to do it. You just need to say y equal to, and then this b right here, it doesn't mean that you know what the y-intercept is. This could be just the number that ends up being the y-intercept, but it doesn't mean that they tell you directly what the y-intercept is. You just need to know what number y is going to be equal to, and it will always end up being the y-intercept, yes. Okay, it's just that we're not going to figure out the b in the normal way this time. Let me show you how we are going to figure it out. Actually, you know what? Excuse me. We need to look at the second one first, though, right now, because as the current problem says, and the current problem is vertical. And vertical means what? Vertical means that the slope is undefined. Let's make a note of that here on your worksheet. We talked about it in the last section, but it couldn't hurt to write it down again. If the slope is undefined, that means that it is vertical. And if the slope is 0, okay, then that means that it is, as we said in the last section, horizontal. Okay. So in this current problem, it's vertical. So when it's vertical, again, you can't plug in the word undefined anyway, and you wouldn't want to. There's an easier way to do it. So again, don't do the mx plus b stuff. Don't do these 2 formulas up here, you guys, when it's horizontal or vertical. In other words, when the slope is 0 or undefined. In the case of undefined, you just have to figure out what number that x is equal to here, and that becomes your equation. And then you might be wondering, well, how do I figure that out? Okay, well, here's the thing, you guys. Let's write this down. When vertical, the thing that's true about a vertical line, you guys, if you haven't noticed already, all of the x's are the same. Okay? And if all the x's are the same, all you got to do is figure out what that one number that's always the same, that's always equal to x, and that goes right here, and then you're done. Remember, the x and the y are a part of your equation, so the x stays the same there. Okay, the x is just like the x's before. This stays the same, and this stays the same as well. But you just got to figure out what the a and the b numbers are, okay, and you got to replace the letters a and b with the appropriate number. But in the case of x equal to a, though, it all comes down to since all the x's are the same, and since the x in this particular point that they gave us is equal to 2, then that means that that's your equation right there. Okay, because if x is equal to 2 in this point, then that means that x is always 2. And if x is always 2, okay, then your equation quite simply is, believe it or not, x equal to 2. That is your final answer. It really is. Because remember, in a vertical line, the y variable is missing. And so it's not a surprise that the y is not there. Okay, and so that's all you got to say. All right. We'll see an example of that kind of thing for horizontal lines here in just a moment here. Okay, but that's what you do for a vertical line. Okay, you just have to take that x number right there for the point they gave you, and then that becomes your equation, x equal to 2. You got to say x equal to 2, though, that whole thing. Okay. Now, in number 5 right here, it says, again, it gives you a point that the line goes through. That's what through means. The line goes through that. But it's perpendicular to x equal to 4. Okay, now we need to talk about perpendicular here for just a moment, okay? This is on the bottom part of the front side of your worksheet here. Let me set things up here for you. Okay, so that we can see it more easily side by side here. There we go. So, all right, now. It says on the front side of your worksheet, as I look at this one on top of the other here, it says that perpendicular lines are slopes that are negative reciprocals of each other. Again, this is on the bottom of the front side of your worksheet. That's where I'm looking. Negative reciprocals of each other. All right. What does that mean? That means... well, it means a lot of different things, and I'll get into that more in the next problem. In this problem, that's not really overly necessary. What we need to realize is that a perpendicular line has a 90-degree angle. Okay, you can see that right here. It says perpendicular lines intersect at a 90-degree angle. Okay, you know, you guys, that this right here, because the y is missing, because the y is missing, this is vertical, meaning this equation that I circled, not the whole problem. Okay, this is vertical. Okay, let me move that up there. Now, here's the thing, you guys. If it says that it's perpendicular to a vertical line, perpendicular to this line, which is vertical, what must be the line that we're trying to find then? What's perpendicular to a vertical line? What's perpendicular to a vertical line is a horizontal line. Isn't that true? Okay. If a line is going straight up and down, okay, we see this all throughout our life, okay? You see lines that go straight up and down like this. Okay, let me show you. Straight up and down like this. And then lines that go straight across like this. Don't they make a 90-degree angle right there in the middle? And that's what perpendicular lines are. They're lines that make a 90-degree angle like that. And so that proves that if you're perpendicular to a vertical line, you must be horizontal. Okay? So, as I just mentioned, you guys, as I promised, if you know that you have a vertical, or pardon me, if you know that your final answer is going to be a horizontal line, what you do is similar to the vertical line example that we just saw. Let me zoom out so we can see it all together at once. When it's vertical, you just take the x number, and then x ends up being equal to that. With a horizontal line, we know that the x is going to be missing. Okay. I know I said y is missing over here, but that was the equation that was perpendicular to the one I'm trying to find. So the one I'm trying to find is a different equation, you guys. So because the new one is horizontal, that means that the x is missing now. Okay? X is missing from the actual final answer, and not only that, but the y is always going to be equal to -4. Okay? Remember in the last problem I said that the x's are always the same if it's vertical? Well, when it's horizontal, the y's are always going to be the same. So all you got to do in order to find the final answer is take the 1 point that they gave you, take the y value there, which is -4, and that becomes your final answer, y equal to -4. Okay, so let's review here. If it's a vertical line, okay, since the x's are always the same, you just take the x that they gave you, and that becomes your answer. Okay, if it's a horizontal line, that means the y's are always going to be the same. Okay, and so you just take the y that they gave you, and that becomes your final answer. Okay, and so that's horizontal and vertical lines. Now here in number 6, notice it says perpendicular to this. Now this is not a vertical line this time like it was on the last problem. Okay, but if it says that it's perpendicular to a line and you don't know what kind of line it is. What you do is you first of all figure out what the slope is. What is the slope of this line? We can figure that out, remember. We did that in the last section, okay? Section 2.4, when if I give you an equation and you want to know what the slope is, you get it into the y equal to mx plus b form, okay? Back in section 2.4, we learned that in order to get it into the mx plus b form, we first of all need to get the y by itself. And that means to treat the y, get the y term by itself by moving the two green ones over to the other side, like this. Put the x term in front. Let me do that. And then you got to divide by -3 in order to figure out what this equation is. Okay? Negative, just like I did in the last section, negative divided by negative is positive. Okay, 8x over 3, and then positive divided by negative is negative, so you put the minus in front of its negative when you're doing this dividing thing here, dividing each term. If it's negative, you put a minus in front. No negatives on the insides of the fractions here, you guys, when you do this. Just a negative in front if it's negative, a plus in front if it had been positive. And you don't need to put a plus in front of the first one, okay? Otherwise, put pluses or minuses in front of each of those two answers there, okay? The two fractions. Put the minus, though, behind. I'm sorry, not the minus, the x. Put the x behind that, just like we learned in the last section. And we get that right there. Now, that's not your final answer. Remember, it says that it is what? It is perpendicular to that line right there. So that means this. That means that this is our slope of that line. Okay. They want us to realize that since the line we're trying to find, you guys, is perpendicular to this line right here, and since it's true that slopes are negative reciprocals of each other when you have perpendicular lines, that means that the line that you're trying to find is going to have a slope that is the negative reciprocal of 8/3. Okay? How do you figure out the negative reciprocal? It's just like it sounds. You first of all flip it, because that's what a reciprocal is when you flip a fraction, right? But then you take the negative of it. That means that if it's a positive fraction initially, 3/8, that means that you change it to negative. And if it had been negative already, taking the negative of a negative would then make it positive. Okay, that's not the case here, but I'm just saying, if this had been negative 8/3, then the perpendicular slope would be positive 3/8. But you basically what you do is you flip the fraction and then change the sign of it. You flip the fraction, you take the you change the sign of it. Those are the two things that you need to do in order to get the negative reciprocal. Okay. Now that I know what the slope is, here's my final answer right here. I know my slope. I know a point on the line, but that is not B right there, because remember, this can only be your B number right here if this number is 0. The fact that this number is 0 makes no difference. The first number has to be 0 in order for this number to be equal to your B number. So you can't say, oh, my B number is equal to this number right here. You can't do that. So I need to fall back once again on that second formula. This one right here, okay, with the x1 and the y1. And we put what? We put, what was that point that we're doing? -2, 0? Okay, so -2, 0. We're going to do that point right there. And we're going to take that and we're going to plug it in to this formula here along with the slope. Okay, so we got what? We've got y minus 0, okay, is equal to, again, just following this formula here, is equal to -3/8 bracket x, and then remember the x1 is negative, and since the minus is already built in front of that number that you're supposed to plug in, that gives you a minus negative. That's a double negative, and therefore it'll change it to +2. Okay. Just like we did in problem 3 earlier, where we had to use the second formula, the x1, y1 formula with the m and everything, you need to get it into slope-intercept form here eventually by doing two things. First of all, you need to clear out the parentheses by distributing the negative 3/8 like that. Okay, and that's kind of getting in my way there, but I just wanted you to see what I was doing. Let me get those little arrows out of the way though so you can see the answer here. Negative 3/8 times x is negative 3/8 x. Okay, again, you're just multiplying a constant fraction times x, so it just becomes negative 3/8 x. And then remember, negative times positive is negative, so this is going to be negative something here, but what is it? Let me just show you off to the side here. You don't have to write down your work on this, but just so you can see what I'm thinking. How do you multiply a fraction, you guys, again, times a regular number like 2? Okay. What you do is you make the fraction for 2 by making it 2 over 1, and then you multiply it together. Yes, you can do some cross multiplying first, though. Just remember, you can't cross multiply unless you're multiplying. So you can do that here since it's multiplication. But even if you don't, you're eventually going to end up with 3/4 here after you reduce the answer. Now that's, remember, that's minus 3/4 because it was negative times positive. Negative times positive. So, but the multiplication part gives you 3/4. So minus 3/4 right there. Now, how do I move over the 0? Well, I need to add it over since it's minus, right? But we all know that when you add 0, what's going to happen? Nothing, right? It's just going to stay the same. So basically, this just cancels out right there because I know that if I move it over, it'll cancel out over here like it normally would. But when I move it over here, it's not going to do anything. It's still going to be minus 3/4. If I add 0 to that, it's still going to be minus 3/4 when I combine like terms. So my final answer is this right here. Okay? And so that, you guys, is the basically what you need to do in order to take a description of a graph, problems 1 through 6 here, a description of a graph, and convert it to an equation that's in slope-intercept form. Now remember, though, if it's horizontal or vertical, forget about all that slope-intercept stuff. Just do the x equal to something or the y equal to something, depending on which type of thing it is, either a vertical or horizontal. But other than that, other than vertical and horizontal, you need to have you need to do the y equal to mx plus b thing as your final answer. Sometimes you need to do that second formula first and then convert it to y equal to mx plus b. Okay, but then there's other times where you can just jump right to the y equal to mx plus b thing because of the fact that you already know what the m and the b are. Okay. So a little summary of that. Let's wrap things up here in this section by looking at this last thing here. I want you to notice in both of these graphs you see here, and let me go and read the directions first. It says, for each of the following lines, write the equation that defines f. Now remember, you guys, f is the same thing as y. I know we've said that a lot here lately, but it is, okay? So they want to know what defines y. What that means, you guys, is that you need to get y by itself. You need to have y equal to something, okay? A correction, you guys, my bad. Although you could say that theoretically, but they want you to write... You know what? I'm going to keep it that way. I'm sorry. I'm going to keep it that way. If they do want us to have it, they want us to have f in the answer, but let's get y in the answer first, and then I'll convert it to f. That'll be the easiest way to do it. So, excuse me there. I want to get y by itself because ultimately I want to get f by itself. Anytime they ask you to define a variable, okay, in this case f, it means that you want to get it by itself. And in the case of f, you can say f of x. That's still considered f by itself, since the f and the x would go together in that case. Okay, f of x. All right, so you can get this by itself here, but we first of all should get y by itself since it's the same thing. And since we're used to getting y by itself already, let's do that first, okay? So ultimately, we want it to look like this right here then. See how this is y equal to, in fact, I'll write that down. This is the same thing as y equal to mx plus b, okay? But after we get the y equal to mx plus b, we'll then just change the y to f of x because they want us to have f by itself. So f of x by itself is what we ultimately want. Okay, what is going to be the y equal to mx plus b in these two problems? Well, as you guys know, the m and the b, once again, are what? They are the slope and the y-intercept. So the question is do you know what the slope and the y-intercept are in these two graphs? I think that we can figure that. In fact, I know we can figure that. I just want you to think about yourself as a student. If can you see here that you're able to figure that out? I mean, I know that we can, but can you see that? Okay, let me show you why you should be able to see that. Okay, this point right here is the y-intercept. This point right here is also the y-intercept right there. Okay, and so therefore we know what the b is. Let's make a note of that. The b here is equal to 1. Why is it equal to 1? The b is always the number where the graph crosses the y-intercept, or where it crosses the y-axis, okay? And so therefore the b here is, b is equal to negative 2 right there, isn't it? So b equal to 1, b equal to negative 2, the b is always where it crosses the y-axis. Okay, so if we can just figure out what the m is, I'm on my way here. Okay, remember, when you have 2 points on a line, you guys, in order to get from one point, and we saw this in the last section here, when you get from one point to the next point, in fact, let me show you, let's just go back for just a moment here, and we'll kind of refresh our memory. Okay, there we go. So we learned in this section here where if you have a point down here and then in order to get to the next point, you always want to start out at the point on the left here, okay, when you do the current problems that I'm about to show you. But if you start out with the point on the left and you have to go up and to the right in order to get to the next point, that means that it's a rise and run thing. Notice this point. This point is on the left and this point down here is on the right, correct? This point's on the left, this point's on the right. If you have to go down and to the right in order to get from the left point to the right point, then that's a negative slope. So let me say it one more time. Starting out at the left point, okay, if you have to go down, up and to the right in order to get to the next point, that means you did rise and run to the right. Rise and run to the right means it's a positive slope. If you have to go down and to the right to get from the left point to the right point, then that must mean that you dropped and ran to the right, and that makes it a negative slope. So now we can actually eyeball, just by seeing it, what the slope is. Okay, how do you get from, you guys, how do you get from the left point to the right point right here? You have to go down 2, 1, 2, and then go to the right 1. So if you do that, then isn't the slope got to be equal to down 2 and over 1 like that? And remember, you do the up or down on the top. You do the distance that you go to the right on the bottom. We always do that with slope. But because I went down and to the right, it's got to be a negative slope. Okay, if I had gone up and to the right, it would be positive. So now we have everything we need, you guys. We have our b, okay, which is 1, and we have our m, which actually simplifies to be negative 2 over 1. So all we got to do, just like we did in the very first problem up here at the top, now that we know the m and the b, we just plug it in and we're done. Other than the fact we need to put the f of x in there at the end. And so we get what? We get the x and the y stay the same, like we said, in mx plus b. The slope gets multiplied by the x, and then the b goes after the plus or the minus, depending on what sign it is, okay? Since b is positive, that's going to be plus. So what's my final answer then, you guys? It is going to be f of x equal to negative 2x plus 1. So again, do the y equal to mx plus b, and then just convert the y to f of x. The purpose of just putting the f of x in there at the end, even though it's the same, is just for us to get used to that f of x notation, getting used to seeing it, getting used to having it in our equations, and just as an added reminder when we do this last step, it reminds us that y and f of x are truly the same thing. Let's try that one more time now. We know the b is negative 2. Notice, though, if you have to go up and to the right in order to get from the left point to the right point over here, okay, if you have to go up and to the right, that's got to be a positive slope. So since I go 1, 2, 3 up, and then 1, 2 to the right, that must mean that the slope is positive 3/2. The 3 for the up part, the 2 for the going to the right part, and then it's positive because we went up and to the right. So we have x and y in our answer. Make sure the slope is being multiplied by the x. And then because the b is negative this time, theoretically I'm supposed to write plus negative 2. But we know that when you add a negative to something, add a negative number to something, it's the same thing as saying minus, isn't it? Like that. And so we'll do that. So this is what the equation is. But again, they want us to put it in the f of x notation. So just take the y and replace it with f of x, since y and f of x are the same thing. And that concludes our section on finding equations of lines, you guys. Again, please don't hesitate to contact me if you have any questions. Take care.